So, let's do part 2 of this Repulsor lift systems video. I missed the bus. My nephew, I guess, is taken back to the elementary school with his brothers and sisters, or their mom picked him up somewhere, I don't know. When I got out there, the bus had driven away. So, anyway, back to this little video. I'm going to show you a little bit of what I've worked on so far. This is not everything, this is just stuff that I had to get out of my head so I could go to sleep at 5 in the morning. So I could turn around and wake up at 9, sometimes 8, just depends. But anyway, this is going to be a quick turn because I'm using a cell phone. So hopefully it doesn't make you sick. If you got motion sickness, look away for a second or two, because here we go. 1, 2, 3. This right here is a brief look of how it'll be laid out. As you can see, it's 3 1/4 inches long by 3 1/4 inches wide by 1 feet, or sorry, it's 3 feet 1/4 inch long, 3 feet 1/4 inch wide by 1 foot 3 inches tall. Okay, as you can see, there's the copper and tin plates here. Goes all the way through. This wire harness also is the copper tube pipe that runs through it, so you can run the copper wiring through there. Your battery on one side, process converter, power converter on the other. That's optional. You really don't need a power converter for this because it runs straight from a battery source. I've got in here a coolant sensor, processor in several places, and coolant pumps. Those are also up to you, really. It will heat up because it is a lot of electricity going through copper and tin and aluminum. So it's up to you. The repulsor casing is the outer one here. Over to this side here, this is a little cleaned up version. As you can see, the darker part here will be the aluminum sheets. The slightly colored one is the copper sheet, and the clear one is the tin sheet. Running through the center, I've got light lines running through the middle of the piping. The sheets here is the copper rod. This is a basic look of the box. It's a graphene case. If you don't know anything about graphene, check it out. It's a pretty decent metal. It's lightweight and it's very strong. We might go into that in another video. Anyway, you got the two locking pieces on the front and back side here. Alright, this is so you can get to it from either side. Here's a look at the back. This is from the top. This is a look from the back. You can see the hinges for the top piece and the front piece and the back piece, bottom piece, top and bottom here. Power lines. These are regular power cables, like jumper cable type setup. You've got one for your negative, one for your positive, and the battery in the middle. This is the bottom view. The battery sits on the bottom. Negative cable, positive cable. Here's your copper rod sticking out the side of the box. Top view. Very plain, very simple, okay? Power converter or power control. This is where the system from your main computer in your cockpit or your driver's seat, if you put it in a car, cockpit if you put it in, like, I don't know, your own little Jedi starfighter or whatever. Power control system hooked up directly to the computer from here. Batteries at the back, power cables. Because you're looking at it from the front view on this piece, this is actually your negative cable, this is actually your positive cable, because it flips when you're looking at it from the back like this. Okay? Let's keep that straight. Anyway, got over here a little piece here. Little note. Bottom is placed facing upwards while the top faces down. The reason for that, you want your box where you can get to it easily. Putting the openings on the bottom, when you get underneath, you can pop that open, slide that out, and make any adjustments or repairs to any of the things that have been damaged through testing or too much power. Note number 2. Power control is a relay from your main computer in the cockpit. It relays the information for more power or less power. This is basically, you turn it on like your car. You turn on the ignition, it initially runs off the battery. Once that alternator belt kicks in, it's all alternator that powers your car. Alright? That's pretty much what this power control system is an alternator. Your initial startup for your power systems will kick on the main system. Once that power control system kicks in, that runs everything. It all coalesces through the battery, but that power control lets you know how much power you're using, whether or not you need to adjust it or to raise it or lower it to get higher or lower in the ground. Alright, so I'll come back to myself. It's really simple. That's just a basic. Okay, I don't know if you noticed the little yellow sheet of paper underneath of the graph paper, but I'll bring that out and I'll show that to you. That's got more in-depth look into it. Alright, it's added a few more things to it, and this, the basic one is the repulsor lift. There's no microwave compressor in there. The one I'm about to show you in the yellow paper has the microwave compressor because that's your repulsor drive. The best way to describe that is the land speeders, your air speeders and your speeder bikes, they have a repulsor lift which takes them up, and then repulsor drive which pushes them forward, slows them down, stops them, things like that. Alright? Repulsor drive, like I said, has a microwave compressor. This adjusts the amount of pressure pushed away from the vehicle in either forward, backward, left, or right, which makes it you can turn sharp, swerve, go up, down, forward, backward. Okay? Now, this is your tin plate, your copper plate. Same as the repulsor drive system, the repulsor lift system, but we've put wood plates, wood slats, in between the tin and the copper because wood is a little bit lighter. You could use graphene, but I'm not sure how well graphene translutes electrical systems. The wood, however, electricity will pass through it. It might catch a little fire, but we've got the ways around that because of this copper rod which runs your wiring. Everything else is placed inside of a box itself, okay? So we got your steel box. I'd still go for the graphene on this because what graphene really is it's steel mixed with nickel. The nickel makes it lighter, but it weakens it. So they add in a couple of other metals like silver to strengthen it back up. You could also add titanium into it if you got a little bit more money. Titanium is pretty good, but you could also add aluminum to it, which will make it stronger as well. Aluminum, nickel, and steel are relatively cheap to get. So you could do that. That makes graphene. You put all this stuff together inside your graphene box, okay? You run your copper tube through there, run the electrical wires through there to your power pack. Your power pack is up to you. I've got two on here. I've got three. One is your main power pack, one is a backup, the other is auxiliary. The auxiliary is what you use when you need more power than what you're getting from your main power pack. The backup power pack is in case one of those craps out. So you can do it like that, or you can do your secondary, your power pack number 2 that I've got listed here as your second power pack to give you more power in your auxiliary pack for one that craps out. I prefer to use the second power pack as the backup for if something craps out. Okay, and your main door is on the top here. Same system wide here. You got your top. This one just pops right off. Electromagnetic microwave compressor top, okay? This sits inside the top casing here. What this is if you know anything about a microwave, that right there, a microwave. Microwaves, basically all it really is a highly condensed electromagnetic wave that is so compressed that it generates heat. Microwave compressor, however, not only generates heat, but it also generates push. You use microwave compressors in lasers, and you can generate a laser strong enough to burn through 12 inches of titanium in a matter of seconds. Okay, titanium melts at like 3,600 degrees. That's not the exact amount, trust me, but it is 3,000 something degrees. 3,600 is my off the top of my head guess. I believe it was like actually 3,246 degrees. But anyway, you can generate that much heat with that much power off of a microwave compressor and a laser. Putting a microwave compressor on an electromagnetic field, which a repulsor lift runs off of, it's not anti-gravity, it's neutral gravity. It negates the gravitational pull on you because it generates a magnetic field around you, which relatively matches the magnetic pull on you. So it's negation, not... It doesn't destroy the magnetic field on you, or the gravitational field, it negates it. It slowly but surely lowers the amount of gravity touching you by how much power you put through it. The microwave compressor magnifies that and pushes you forward. Alright, so here's the way it works. Your electromagnetic coil plates. You can use diamagnetic or dielectric or both. You can actually get them combined together, so you get diamagnetic electric plates. You place these in, same as you would with this. However, instead of putting spacers between them, you set them side by side. The more you put, the stronger your magnetic field will become. Alright, you collect it to a power pack. This is your electromagnetic microwave coil. Compression coil. This little guy here. Top. This is your power pack. Your repulsor lift. Top. This is your power pack. This is your electromagnetic coil power, a secondary one, and the power pack for that. The reason these are on the side is because the microwaves will congeal in the center of this, and depending on how you angle these plates is which direction they go. My recommendation, one side goes vertically toward your power pack here, the other one goes away from the power pack. That way, when you initiate this one, if you're going forward, this one facing the front will slow you down. This one facing the back will push you forward. You can make these maneuverable like the ailerons on a jet. When you want to go up, it goes up, which pushes the back of the plane down and the front of your plane up. You want to go down, it pushes down, which pushes the back of your plane up and the front of your plane down. You can do that with these to move them to face like this, forward or backward, flip it either way. So you can do more power backward, more power forward to slow down from extremely fast paces. Neutralizing them, facing them together, which straight on like this, it generates a microwave forward and backward like this and pushes inward and outward. You can use that as a turn or a swivel, so you can dodge things, you can actually make a sharp turn. The G-forces in sharp turns I would not recommend with these until you figure out how to make the inertial dampener, which I may go into at some point, depending on how many comments we get on going into that. I'm still working on it, but it's based off of an electromagnetic field around yourself and your cockpit and basically the rest of your ship, so it holds together without the gravitational forces ripping it apart. It still needs a little bit of work. I'm still working out fine little kinks in the systems and how to make it all coalesce to what you need and what you want out of it. But that's the basics of it. Your electromagnetic fields is your repulsor lift. Add a microwave compressor. That's your drive. Alright, have a good day.